Hello friends, today we'll discuss about the interpolation search. So before moving to interpolation search, let's discuss about the complexity of linear search, binary search and jump search. The complexity of linear search is order of n, complexity of binary search is log n, and complexity of jump search is root of n. I have already uh, explained everything. So let's say n is equal to 2. So the complexity of this will be 2. Complexity of log 2 with base 2 and complexity of jump search will be root of 2. So this is order of 2. Let's say this is 2. This is 2 with base 2. This will be 1 and this will be 1 comma 1 4. So what does it mean? It means jump search lies between binary search and linear search. So the order is binary search performs well, so which is 1, jump search takes 1.4 and linear search take 2. So this is the order of performance of these three algorithms. Now we are going to move to the new very important algorithm which is called the interpolation search. So what is the idea behind the interpolation search? So before move to interpolation search, let's know that jump search performs well when you are looking for an element which is supposed to be present at the start of the array, because you divides your array into multiple blocks and you start searching element from the starting of the array. So if your element is expected to be at the start of the input, then always use the jump search. Now move to the interpolation search. Now the idea behind the interpolation search is data should be already sorted and evenly distributed. Means the distribution should be like this. It should not be skewed distribution. So interpolation search use the human intelligence. So what does it mean? Let's say you are searching a word algo in a dictionary. Okay, you are searching a word algo in a dictionary. You know that all the dictionary words fall in this range A to Z and they are evenly distributed. Means all the words start from A first, then the words which is starting from B comes, then the words which is starting C comes after that. So the words are starting, all the words with A falls come first, then all the words with B come second, then all the words with C come third and all. So if you are searching for a word algo, it is an human intelligence. You know that it should be somewhere at the starting of the dictionary. So you will look into this section. Okay. Now if you are looking for a word Zen, so you know that it should be somewhere at the end of the dictionary. So this is a human intelligence. Now interpolation search use this human intelligence for finding a word, for finding a key in a sorted input. Okay, so let's let's try to know how to do that. How interpolation search this human intelligence. We know that in binary search, in each iteration, we find the position of the middle element with this formula r plus l by 2. R is the starting index, L is the ending of the index. But in the interpolation search, we use a interpolation formula. So in which we are looking for a key k. So how do we calculate the position in each iteration? It is somewhere like so the position can is calculated by this formula. This is the key which you are looking for, right? And from the key you are subtracting your starting element. Okay, now you are dividing last element minus starting element and last position minus starting position. Let's try to understand this with the help of this example. I want to search a key 6. So k is equal to 6 minus AL. This is my AL minus 1, AR 7 is my AR, AL is 1 into R minus L. R is equal to 6 and L is 0. So this will be 5 minus 5 bata 6 into 6, 6 into 6, 5. So my 6 is present at 5 and my data is equally distributed. Now let's suppose I want to look for key 2. So now my k is 2, 2 minus AL, AL is 1, AR is 7 minus AL is 1 into R minus L, 7 minus 1. So now these will be cancelled out. So the 2 minus 1 will be 1. So my key presents here. So this is an interpolation formula, mathematical interpolation formula. It uses the human intelligence to find the index. So now the position for my key 2 is this, and position for key 6 this. So this is somewhere better than the binary search, because if you do the same thing in the binary search, so at very first iteration it will give 4. Okay, since we are looking for 6, then it will do the same thing into the right of the right portion. Okay, so let me give you the pseudocode for this. Now this is the pseudocode. So few boundary conditions are missing in this code, so I'm not caring about that. So this is my formula for calculating the position, which I have already explained. Now if element at this position is equal to the key, then return the position. If element at this position is smaller than the key, so it means your key lies somewhere at the right of at this index. So your L will be, you will start at the right of the index. Otherwise your element lies in the first half of this, I can say at the below of this position, previous to the left to this position. Okay, so let me explain the time complexity for interpolation algorithm. Before we move to calculate the time complexity for interpolation search, let's try to calculate the complexity of binary search. So I am giving this example because it will help to understand. So what is the binary search? In binary search, we divide by our input by 2 every time to get the input size as 1. Now how many times I divide? So let's say it's 2 to the power x. Okay, every time I'm dividing my input to get the array size as 1. So when array size is 1, so it means you have found your elements. So 1 is equal to n by 2x. Okay, we are dividing again and again by 2. So now let the log of both sides, or I am taking the log as with base 2. Why with base 2? Because every time I divide my problem into two halves. Okay, every time my problem is divided into two halves, so that's why I'm taking log with base 2. So now, okay, now take the logs. So before taking the log, just multiply both sides by 2 to the power x. So it will be 2 to the power x is equal to n. Okay, now take the log with base 2. So it will be log with base 2, 2 to the power x, and log with base 2n. Now x will come first, so log with base 2 and 2, and log with base 2 and n. You know that in logarithm formula, log with base a and a is always 1. So this will be the 1. So x is equal to log 2 of n. So means these many iteration will require to get the 1, because we are looking for the value of x. How many times I divide this input by 2, since so I easily get the 1. So you need to divide this input by log 2n. So it means the time complexity for binary search is log 2n. Now in the interpolation search, what is the difference between binary search and interpolation search? In the interpolation search, the constant is different. what I'm trying to say is, in your binary search, C was 1 by 2, right? But in the interpolation search, this C is different. What is this C? This C is your K minus A L A R minus A L and R minus L. Okay. So for simplicity, to do the calculation, I am writing it like this. So I am writing this as K minus L and R minus L. For simplicity, we will replace this later. So what does it mean? It means for interpolation search, you are looking for one single element when your matches happen, and you are doing this thing for how many times? X times. You are doing this thing for X time, and you are looking for the value for this X. So we need to find this X. So before that, let's simplify this. So this will be R minus L, X is equal to N K minus L X. Take the log with base 2. Why base 2? I have already explained, because in interpolation search also we divide our into two multiple halves. So this will be log with base 2 R minus L log with base 2 N into K minus L X. Now this will be by logarithm multiplication. This looks like log with base 2n plus log 2 k minus L to the power x, and this will be log 2 r minus L to the power x. Okay, let's simplify this. Now take this term in this side. So before that, this will be x log 2 r minus L, because x will come first with the help of logarithmic formula, logarithmic property, and log 2 x k minus L log 2n. Now by logarithmism we know that, okay, so before that just take x as a common. So this will be log 2 r minus L minus log 2 k minus L log 2n. By logarithmic property, log a by b can be written as log a minus log b. So this will be x log with base 2 r minus L k minus L log 2n. Okay, now divide both sides by this log 2 r minus L k minus L. So this will be 1 by log 2 r minus L k minus L into log 2n. We know that by logarithmic property, log with base 2a, 1 by 2 log with base 2a is equal to log a, log with this base a and 2. So these two are just reverse. So it will look like x is equal to log. Now this term will be my base. So this will be r minus L k minus L into 2 and log 2n. Okay. So the time complexity, number of iteration of x will be equal to log, I am representing this complete term as a c, to log 2n. Now what is the c? Initially my c was, c is equal to k minus L. So we need to reverse it, sorry. because we are reversing, so it will be k minus l and r minus l, k minus l, r minus l, and what was that, r minus l. These are the indexes. Now if the value for this c is 2, then this will work like a binary search. So let's try to know that. If the c is 2, so if the c is 2, then log with base 2 and 2 will be 1. So if this is 1, then x will be log 2n. So what does it mean? If your interpolation formula, every time if your interpolation formula gives your input as a 2, so it means your interpolation algorithm complexity will equal to the binary search complexity. Otherwise, this will be log 2 and log 2n. Since I am eliminating log 2 here, 2 as a term here, so the complexity will be log c log 2n. We cannot combine these two logs because both have the different base. That's why I eliminate 2 here. This is base c and this is base 2. Okay, so let's try to understand how it's look like a binary search. So let's say 1 2 3 4 5. I'm looking for 3. Okay, so for 3, so this, if I put 3 in this formula, this will be 3 minus 1, 5 minus 1, okay, and 4 minus 0. So this will be 2 by 4 into 4, this will be 2. So if I put, this is 2, if I put 2 here, then this will be 1. So the complexity of interpolation search will be equal to the binary search if every time this gives the middle element. Okay, so this is the explanation of the time complexity of interpolation search. So interpolation search time complexity is log with base 2 n. Thanks for watching. Please subscribe my channel.